So we've been asked to find the equation of a tangent line to this function at a particular coordinate point, in this case 2, 7. Now, the equation of the tangent line will take the form y equals mx plus c. Just a standard linear equation. Now, what we're going to have to do, the method that we're going to have to solve this is we're going to have to find m first, and then we're going to use the coordinate point to find c. So to find m, we have to first find the gradient function of this, or take the derivative of this function. So that's what we're going to do to start with. I'll write that down. We've got number 1, we have to find m. Okay. So we're going to take the derivative of this. So to do this, we're going to use two different rules. We're going to use the product rule because we have one function multiplied by another function. And we're also going to use the chain rule because here we have a inside function and an outside function. So, okay, so to do this, we're going to get the derivative, or f prime of x. This is going to be equal to, we'll use the product rule to start with, the derivative of the first function multiplied by the second function. So the derivative of the first function is just simply 3 multiplied by the second function, which is just x squared minus 3 all cubed. And we're going to add that to the derivative of the second function. Now, the derivative of the second function, we take the 3, we move it out, we use the chain rule. So we go 3 times the inside, x squared minus 3. We drop the power by 1, to 2. And then we multiply that by the derivative of the inside, which is simply 2x. And then we multiply that by the first function staying the same. Cool, so that's our derivative. Now, to find m, we need to know what the gradient is at the point x equals 2. So that's what we're going to do. So at x equals 2, we're going to take f prime of 2. And we're going to basically substitute 2 in. So we're going to have 3 in brackets 2 squared minus 3 all cubed plus 3 bracket 2 squared minus 3 all squared times 2 times 2 times 3 times 2 plus 1. Cool, sorry about my handwriting there. So this is just a little bit of arithmetic now. 2 squared is 4, minus 3 is 1, cubed is still 1, times 3 we have 3. And we're going to add that to 2 squared is 4, take 3 is 1 again, squared is still 1, times 3 is 3. Now we have, so 3 times, we've got 4, and then we have 3 times 2 is 6, plus 1 is 7. Cool, so 3 7s are 21, times 4 is 84, plus 3 is 87. So m in our equation, in our tangent function, is going to be equal to 87. So what we then have to do, the next step, is we've got to find out what C is. So step 2 is we have to find C. So we now can sub in our m value to our tangent function. So we're going to have y is equal to 87x plus c. Now what we're going to do is we're going to get this coordinate point here and we're going to substitute it in here. So we're going to put 2, 7 into here. So we're going to say that 7 is equal to 87 times 2 plus c. So we can say therefore c is equal to 7 minus 87 times 2 is 174. So c will equal negative 167. Okay, so there's our c value. So what we can then do is once we've got our m value and our c value, we can get both of those and write down the solution to this problem. So you can say therefore the equation of the tangent line at the point 2, 7 is y equals 87x minus 167. And that's the solution to the problem.